Welcome to Mathematics Lecture Series. It is lecture number 6 in Applied Calculus series. Today we discuss more about the functions. Before the start of lecture, I request you kindly subscribe the channel and share the video and like also. We discuss circle. X square y square is equal to r square is a circle with center 0, 0 and radius r. With radius r, from which we have y square is equal to r square minus x square. Just by rearranging, we will have the value of y plus minus square root r square minus x square. So you can see that if we put one value of x, we will have exactly two value of y. So in fact this is not a function, because in domain we have for one value two images in codomain, so it is not a function, and moreover domain of f is minus r and r. Now y is equal to square root r square minus x is the upper semicircle, and the equation, if we consider minus r square, is represent lower semicircle, upper and lower semicircle. These are both functions, and also they are called the branches of circle x square y square r square. Now observe that x square plus y square is r square can also be written as x square minus y square. X is equal to plus minus r square, means we solve this equation in x, so we will have to, since x is a positive on the right of y-axis, therefore graph of x is r square is the right semicircle, and this left semicircle, minus represent left semicircle. The circle s square plus y square is equal to 1, whose center is at origin and radius is called a unit circle. So some square root function f of x square root of x, x is greater than equal to 0. If you observe that this graph, of course it graph covers just positive real numbers, so domain of f of this graph square root function is positive real numbers. Square root of function defined by this, f of x mod x greater than equal, the domain of the square root function consists of all non-negative reals, means positive, that is x greater than equal to 0, because square root of a negative number is not a real number. Graph of this function, so you can also check the graph. From the graph you can see that this is just a cover positive real numbers, so domain of f of this function is positive real number. Cubic cube function, observe the graph of cube function, it covers all real numbers, so domain of this function is all real number. F of x cube, x belongs to, or the domain of this function is all real number. Graph is shown. Reciprocal function, observe that this reciprocal function, so here must be x is not equal to 0, so without real, all it covers all real number minus 0, so domain of this graph real number minus 0. Constant function, observe f of function from real to real can be defined by f of c for all x belongs to R, c being a fixed real number. Such function known as a constant function. So domain of this function, constant function, is all real. You can define the constant function for all real number. Function f of c is a straight line parallel to x-axis. F of x is equal to 0 represent the x-axis. This is the equation of x-axis, and f of c is a straight line parallel to x-axis. Identity function, this is a graph of identity. You can see that graph covers all real number, all real, x-axis covers. So a function f for r to defined by f of x for all x is called the identity. This graph is straight line passing through the making angle of 45 with the x-axis and y. Domain of f is all real numbers. The absolute function that is from real to real, if you observe that it just covers y-axis for just a positive y-axis. So domain of f is all real number, but range of f just a positive real number. So the graph consists parts of x minus above the x. It may be noted the function is you denoted by f of x. It is also known as a modulus function. You can also write the graph y mod x minus 1. Just one unit. Take this graph to below of that. So this is a graph of y mod x minus 1. And graph of y mod x plus 1, just take one unit to upward of that graph of y mod x. Similarly, you can also write from that y mod x graph of y mod x plus, just take one unit right hand side of that graph y mod x, and that is y mod x minus, take one unit left side of that graph y mod of x. There are very important function, the bracket function, or we can, there are two bracket function, greatest integer function, a function whose value at any number x is the greatest integers then or equal to x is called greatest function and is usually denoted by f of x. This is in bracket x. This is also known as a floor function because of the behavior of the graph is just like a floor. So here is defined this f of x is equal to 0 whenever x between 0 and 1, 0 less than equal to x. So minimum value covers the of that interval. 1 less than equal to x2, what's the f of x1 minimum value? 2 less than equal to x less than 3, minimum of that 2. So here in that, for that 3 less than equal to x, x less than equal to 4 is 3. Here minus 1 less than equal to, so in fact here the less minus 1 minus 2 minus 3, and you write the graph here, it is 0, this is 1 node here 2 3. So if you locate all these points, you will have graph is just like a floor. Here observe that f of 2.4 in bracket it is equal to less value, f of 1.9 is less 1.9 is equal to 1. So observe that this is a discontinuous function. There are many discontinuities, and it may noted the domain of f. Domain of it covers all this x-axis fully. It covers totally x-axis. So domain of f is a real number, whole real number. The least integer function. Similarly, although the least integer function whose value at any number x is the smallest integer. It takes the smallest integer, minus 2 less than equal to x less than equal to minus 1. So what is the highest, smallest value is minus 1. Here minus 1 less than x, x less than equal to 0. So it takes 0, 0 less than x, x less than equal to takes 1, 1 less than x, x less than equal to takes 2, and here is a 3. If we write these points on nodes here, take the interval 0 0 and minus 1 to 0, so it takes here node, and here for the interval 1 2 it takes 2, we take the node. It's a discontinuous function. Observe here f of 3 in bracket is 3, f of minus in bracket minus 5 is minus 5, f of 2.4, so 2.4 least integer is 3. So observe that this graph covers all positive real number on x-axis. So domain of f is all real number. It is range, it covers all y-axis, positive, negative. This graph covers whole y-axis, real number on y. So range of this function is all real numbers. And of course this is a discontinuous function. There are many discontinuities you can see here. The sine function. The the sine function is a piecewise function. Sine function is equal to 1 whenever x greater than 0. Sine function is 0 when x 0. Minus 1 it is then x is less than 0. So right here, this is a portion x greater than 0. Of course, this is here is a 0, here 1, 2, 3. So this from without 0, this whole x is covers x greater than 0. So sine of function it is equal to 1 for every real number which is greater than 0. And at the point 0 it is sine x is gives 0. So for the x less than 0, of course here is on x is x less than portion, so it gives minus 1. The sine function is shown for x not equal to 0 when sine was defined. So here domain, what is domain? Here domain is f is the real number minus just 0, because on at the point 0 sine function gives 0. Piecewise function, piecewise, this is also piecewise function, sometimes in different formulas on different parts of its domain. Such type of function are called piecewise function. For consider the function f of x minus x. So whenever x less than 0, here is a x less than 0 portion, so it gives f of x minus x. F of x is equal to x square whenever 0 less than equal to x, x less than. So from 0 to 1 it gives a parabola branch f of x, x square. X greater than 1, here is a 1, so here this portion is a greater, it gives f of x gives 1. So it's defined on the entire real line but has values given by different formula depending on the value. The graph of this function drawn by applying different formulas is given in the function. Application of a piecewise function will be presented in the next lecture.
Say more about the function polynomial function in equation an expression a n x power a n minus 1 x n minus 1 and so on a2 x square plus a1 x plus a naught is known as a polynomial degree, and hence the function of the form f of x a naught x n until plus a naught is known as a polynomial. Domain of the polynomial is a set of all real numbers. A function is called algebraic function if it is can be expressed the sum, difference, product, quotients, power or roots of the polynomial, as f of x 2x plus 5 is minus 7 the polynomial function. G of x square plus over x minus 2 is a polynomial function. H of x is square root x square plus a polynomial function. Here k of x are algebraic function. Transcendental function that are not algebra are known as a transcendental function. The combination of algebra transcendental is also known as transcendental. Such function can certain any trigonometric, inverse trigonometric, exponential, logarithmic function. For example, f of x cube plus square root x minus plus cos x minus plus log is a transcendental function. Bounded function. A function from real to real is said to be bounded if range of is a bound, otherwise it is called unbounded function. For example, f of x is equal to square root 4 minus x square. Here this is a bounded because this range is a closed interval minus 2 and this function represent the upper half of the centered at origin and radius is 2. The function f of x square is plus 1 are unbounded function because the range is a set of all non-negative real numbers, and that of g of x is the set of all real numbers. Both sets are unbounded, hence f of x and gx are unbounded function. Thank you. We have covered more about the functions. I request you kindly subscribe the channel as you find more videos on the applied calculus topic. Thank you.